All right, this is Honors Algebra 2 Pre-Calculus. We are doing 5.3 in Pre-Calc, which is solving trigonometric equations. So we solve trig equations the same way we solve other equations. We start by solving down to the trig function the same way we would solve down to the logarithm way back in Chapter 6 of Algebra 2. Some basic hints. Just like when you normally solve, you would combine like terms if you can. If there's only one trig function, you can usually use SADMEP, which is just order of operations in reverse, right? PEMDAS backwards. If there are multiple trig functions or multiple powers of the same trig function, you're probably going to have to factor. And sometimes you need to use some trig identities to alter the expression before you can factor and solve. So once you've solved down to the trig function, you use your unit circle knowledge, or if it's not something on the unit circle, your calculator to find the angle. So let's go ahead and walk through this. All right, so we're actually going to solve this in two ways. We're going to solve for the value on the given interval, which is just one full trip around the unit circle. And then we're also going to solve for all real values, meaning every possible value, not just the ones in the window of the first round of the unit circle. So let's go ahead and solve first. So I'm going to start by moving all my cosecants to one side. Since there's already a cosecant by itself on the right-hand side, I'm just going to subtract 2 cosecant theta to the other side. So 2 cosecant theta, and I'm going to get negative root 2 equals negative cosecant theta. So I seem to get that root 2 is cosecant theta, right? So remember that this is 1 over the y on the unit circle, right? Y unit circle, right? So I'm looking for essentially places where the y on the unit circle is a positive root 2 over 2. Now, it's great if you can just picture this in your head. That's the pi over 4s here and here, right? If you can't picture it, so I'm just going to pull up a unit circle for a sec, right? So that's pi over 4 in quadrant 1, which is right here, and also the pi over 4 in quadrant 2, which is 3 pi over 4. If you can just picture that, that's awesome. If you can't picture it, keep practicing memorizing the unit circle, because this is when you're going to need it, is when you're solving trig equations, or when you're finding different zeros of some trig functions, you're going to need that information. So I get that it's these two values, right? So my answer, right? So my answer for part A, which is in the given window, is going to be that theta is pi over 4, or theta is 3 pi over 4, and those are my two answers. The trick is that when I'm asked to find answers for all real values, I'm going to say that any angle that is also coterminal with those would also be okay. So I'm going to get that theta is pi over 4 plus 2n pi, which literally just means n full circles in either direction, right? So if this point works, right, if pi over 4 works, then this point, which is 1 full circle extra, would also work. And so would this point, which is 2 full circles, and so on and so on and so on forever. The other value I'm going to get is that theta is 3 pi over 4 plus as many full circles as I want. And so those would be my answers. If I weren't given a window, I would say every possible coterminal angle to 3 pi over 4 is 3 pi over 4 plus 2n pi, where n is an integer value. All right. So you're going to go ahead and try P1, same idea. So first thing I would suggest you do is subtract the 3 cosine theta. So you're going to get root 3 equals negative 2 cosine of theta. Root 3 over a negative 2 is your cosine of theta. Well, that's your x on the unit circle, right? So you're looking for where x on the unit circle is a negative root 3 over 2, right? And that's going to be here and here, right? And again, if you need to, you can definitely pull up a unit circle, right? And you can see that my x-coordinate is a negative root 3 over 2 at 7 pi over 6 and also at 5 pi over 6, right? So my two answers for A are 5 pi over 6 and 7 pi over 6, right? And then for B, it's going to be those same two answers, but each one of them is going to have 2n pi added to them to mean I can add as many full circles as I want, and it would still be coterminal. So those are my two sets of answers. All right, let's keep going. All right, so now we're going to go ahead and solve this. Now this time I have a cosecant squared and also a regular cosecant. So because I have multiple powers, right, because I have multiple powers of my cosecant, right, I'm probably going to have to factor, right? So remember, rule number 1 of factoring is that one side equals 0, so that's good. That side's already 0. And I look for a GCF, and I get that the GCF is cosecant x. and I'm left with cosecant x plus 2. So either the cosecant of x is 0, or the cosecant of x plus 2 is 0, meaning the cosecant of x is a negative 2. Well, this is 1 over the y on the unit circle is supposed to be 0, and that's not possible, right? So there's a couple different ways to figure this out, right? One of them is that if a fraction is 0, it means the top is 0. Well, 1 is not equal to 0. In fact, all of the computing that you use in your daily life is built on the fact that 1 is not equal to 0, right? So it's not possible because the numerator is a 1. A 1 can't be equal to 0. The other way to figure out that it's not possible is if you think about what a cosecant graph looks like, right? A cosecant graph essentially looks like this. See how it never crosses 0, right? So this is 0 in the middle, but a cosecant graph is all those hats and shoes, right? It's the cosecant of x can't be any value between -1 and 1 exclusive, right? It can't be values between -1 and 1. So there is no answer there. But 1 over the y on the unit circle absolutely can be a -2, because that would mean the y on the unit circle is a -1/2. Well, the y on the unit circle is a -1/2 here and here, right? And you can see that again if we pull up our unit circle, right? Sorry, we're a little slow to... There we go. All right. So here's my y on the unit circle being a -1/2 right here at 7 pi over 6 and right here at 11 pi over 6, right? So my answer to A would be that x, because it's an x not a theta this time, is a 7 pi over 6 and an 11 pi over 6, right? And my answer to B would be that x is 7 pi over 6 plus 2n pi and 11 pi over 6 plus 2n pi, which really is just our way of saying every possible full circle that could be added or subtracted. All right. So go ahead and try at P2. Again, you're going to be factoring here, right? Notice one side already equals 0, so that's dope. My GCF seems to be a cosine of x, and what I'm left with is 2 cosine of x minus 1, right? So either cosine of x is 0, or 2 cosine of x minus 1 is 0, giving me the cosine of x is a 1/2. Well, this is asking me where the x on the unit circle is 0, and that's here and here, right? And this one's asking me where the x on the unit circle is a 1/2, and that's here and here. So it seems to me that my answer to part A is, let's see, it's an x not a theta, is x equals pi over 2, 3 pi over 2, pi over 3, and 5 pi over 3. Now, there's a little bit of a trick here. So there's 2 ways to write B, okay? It would be totally okay to write literally all 4 of those plus 2n pi. So one way to write it is pi over 2 plus 2n pi, 3 pi over 2 plus 2n pi, pi over 3 plus 2n pi, and 5 pi over 3 plus 2n pi. That's one option, and that's totally fine. So that's great. Okay, this is fine. All right, that's all great. But there's another option, because these two are exactly a full line apart. You could, instead of adding 2n pi, you could add pi. So you could actually combine these two into a single answer. The other way to write this is to say that x is, you could do pi over 2 plus n pi instead of 2n pi, because this would be half of a circle and half of a circle and half of a circle, and then list the other two. You can't use that trick on the other two, because for the other two, they're not a straight line, right? Like this isn't half a circle, like this is a full, that's like Pac-Man, right? So for these two, you can't combine them, but just throw, like this is another way to write it. I don't have a preference. The only reason I would mention it is because if on a multiple choice question you saw both options, you should just, or you wouldn't see both. If on a multiple choice question you came up with this option, but this is the option they had, you should just understand it's the same answer. All right, let's keep going. Go ahead, we're going to try an E3, right? So E3, there's only the one value of cotangent, but it's a cotangent squared. So I'm going to go ahead and solve down with SADMEP, right? So I'm going to do subtraction, addition, division, multiplication, exponents, and parentheses. So I'm going to go ahead and add the 1 first, right? So 3 cotangent squared of x is a 1. Cotangent squared of x is a 1/3. When I take the square root, and this is the big important mistake a lot of people miss, I need to write a plus or minus. So this is a plus or minus 1 over root 3. So remember that this is the x on the unit circle on top of the y on the unit circle. And remember that although this is so this is the right answer, but on the unit circle, right? So on a unit circle, these would be over 2. So I'm going to go ahead and multiply both the top and bottom by a half. And what that means is I'm looking for a plus or minus where the x on the unit circle is a half and the y on the unit circle is a root 3 over 2. This plus or minus means that all of the quadrants are fair game, because I don't care if the net result is positive or negative. I just care that I end up with an x that's a 1/2 and a y that's a root 3 over 2. Well, the x's are 1/2 and the y's are root 3 over 2 at the pi over 3's, right? So my answer to A is going to be x equals pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Okay, so that's my answer to A. Now there are 2 ways to write my answer for B. My answer to B can either be written as all 4 of those, right, separately, plus 2n pi. So pi over 3 plus 2n pi, 2 pi over 3 plus 2n pi, 4 pi over 3 plus 2n pi, and 5 pi over 3 plus 2n pi. That's fine, okay? Or you could recognize that these two, right, the pi over 3 and the 4 pi over 3 are a pair, and that these two also make a line. So the other way to write this, and again, I'm not judging, I don't care which of the two you pick, the other way to write this would be x equals pi over 3 plus n pi, because that would cover, I did that one in blue, so pi over 3 plus n pi would cover both this one and this one. And 2 pi over 3 plus n pi would cover both this one and this one. So that's the other way to write B, okay? Again, I don't care if you see that trick. I just need you to be aware that it's the same answer. All right, go ahead and try a P3. I'll do it while you do it, right? So again, I'm going to go ahead and use SADMAP. There's only the one power of the trig function, so I'm going to go ahead and do subtraction and addition first, right? And then I'm going to do division and multiplication, and then I'm going to deal with the exponent. So remember, when I take a square root, I have to write plus or minus. So I'm going to get that this is a plus or minus root 3 over 2. So I'm looking for where the x on the unit circle is a plus or minus root 3 over 2. That's what I want to find with my eyes. Well, the x on the unit circle is a root 3 over 2 at the pi over 6's. So I want these 4 values, okay? So my answer to A is going to be x equals pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6, right? So that's my answer to A, those 4 values. But my answer to B can be written one of 2 ways. I can either list all of those values plus 2n pi, which is totally fine. So pi over 6 plus 2n pi, 5 pi over 6 plus 2n pi, 7 pi over 6 plus 2n pi, and 11 pi over 6 plus 2n pi. That's fine. Okay, that's one option. Or, right, so or, and we've seen this in a couple other examples, these two make a straight line. Like this guy and this guy are paired up together, right? So I could write this as x equals pi over 6 plus a half circle, which would cover both this and this. And these two make a straight line. So I could write this as 5 pi over 6 plus the half circles. Okay, so that's another way to write the answer to B. You don't have to write both, you just pick one of them. All right, so let's do an E4 and a P4, and then I think that's it for this part of this video. All right, so same idea, a little bit trickier. This is a secret quadratic trinomial. So you've seen these before. It's sort of, so this is like when you used to see things like x to the 4th minus, let's say 4x squared plus 3. And you'd say, oh, I get it, u is x squared. So this is u squared minus 4u plus 3, and then you would factor, right? So it's like that, okay? The difference here is that my u is sine, which makes this a u squared. So this is 2u squared plus u. So what I'm doing is I'm saying, hey, this u is sine plus 2u minus 1 is 0. This is going to factor into a 2u and a u, a plus 1 and a minus 1. So I'm going to get 2 sine of x minus 1, and I'm going to get a sine of x plus 1. So either 2 sine of x minus 1 is 0, which is going to give me sine of x is a 1/2, or sine of x plus 1 is 0, which gives me sine is a -1. Well, all of those are values in the unit circle, right? So this is, sorry, I didn't mean x. This is where my y on the unit circle is equal to a 1/2, right? And this is where my y on the unit circle is a -1. Well, y on the unit circle is a 1/2 here and here, excuse me. So at x is pi over 6 and 5 pi over 6. And y on the unit circle is a -1 here, which would be at x is 3 pi over 2. So when I go to answer right here for A, right, my answers are going to be that x is pi over 6, 5 pi over 6, and 3 pi over 2. When I go to answer for B, none of these pairs make a straight line, right? Like these don't make a straight line, and that's not paired with anybody. So I'm just going to have to list all 3 of them separately. So pi over 6 plus a full circle, as many as I want, right? 5 pi over 6 plus as many full circles as I want, and 3 pi over 2 plus as many full circles as I want. Okay? All right. So go ahead and give this a try. Again, this is one of the secret quadratic trinomials, right? So I have a cosine squared and I have a cosine, right? So I want to call u cosine, and that's going to make this 2u squared plus 3u plus 1. So that's going to factor into 2u and a plus 1 and a plus 1. So I'm going to get 2 cosine squared, or it's not squared, my bad, 2 cosine x plus 1 and cosine x plus 1. So either 2 cosine x plus 1 is 0, which is going to give me cosine x is -1/2, or cosine x plus 1 is 0, which is going to give me cosine x is -1. Well, that's where the x on the unit circle is a -1/2, or the x on the unit circle is a -1. Sorry, meant -1. So x is a -1/2 here and here at pi, 2 pi over 3 and 4 pi over 3, and x in the unit circle is a -1 here at pi, right? So my answers are going to be for A, x is 2 pi over 3, or pi, or 4 pi over 3. And for B, since none of those make a straight line together, I'm just going to have to list all 3 of them separately. So 2 pi over 3 plus 2n pi, pi plus 2n pi, and 4 pi over 3 plus 2n pi. And you won't generally be asked to do both A and B on like a test question. I just think it's easier to consolidate our examples and walk through both skills now. And I think that's it for this video. Yep.